Good morning. Today we are going to be talking about graphing reflections on a coordinate plane. So first thing we're going to do is watch a video.
Good grammar and spelling are important, but if you want to write essays that inspire,
Reflections of points. So what exactly is a reflection? Well, a reflection is a mirror image of a figure or point on the opposite side of a line. So here we have a reflection in nature, and this mountain is being reflected in this body of water. And I just drew this line here, but you can see how it's being reflected across the line. Here's another example. It's just a line that I drew here, and that landscape's being reflected. And there's one more little example. Now in math, we can reflect points, we can reflect lines, we can reflect shapes, and we do this on a coordinate plane. So let's take a look at this. What would happen if I took the ordered pair 3, 3, and I changed the x-coordinate? Now remember, the first coordinate is your x-coordinate. So what would happen if I changed it from 3 to -3? Well, look what happens. It ends up jumping or reflecting across the y-axis. So when I changed the x, it reflected over y. Well, what would happen if you did the opposite? What if instead of changing the x, I changed the y, and I changed it from 3 to -3? Well, look what happens. Instead of jumping over the y like it did last time, it's jumping over the x-axis. So when you change the y, it jumps over the x, or it reflects across the x-axis. Well, what would happen if I took both of those points and I took the opposite of both those points? So instead of 3, 3, I did -3, -3. Well, this is interesting. Look what happens. It actually ends up reflecting across the x, and it ends up reflecting across the y. It reflects across both. So let's try a couple of these. Here we have the point 7, 3, and I want to reflect across the y-axis. I want it to reflect across the y. Well, remember, if I want it to reflect across the y, change the x. So I'm going to change the x from 7, 3 to -7, 3. -7, 3. So look what happens. It reflects across the y-axis. Let's try another one. Same thing. I have a point here, 7, -9, 7, -9, and I'd like to reflect again across the y-axis. So to do that, if you want to reflect across the y, change the x. So I'm going to change the x from +7 to -7. So I'm going to do -7, -9. And -7, -9 would be located right here. This is -7, -9. So it's reflecting across the y-axis. Let's try some over the x. Let's reflect over the x-axis. How do you do that? Well, here we have the point -6, -4. And I want to reflect, this time, across the x-axis. Well, if you want to reflect across the x, change the y. Take the opposite of the y. So the opposite of the y would be +4. So -6, +4 would be right here. -6, +4. So you see how it reflects across the x-axis.
Okay, so when you want to cross the x, if you want to reflect across the x-axis, you change the y. If you want to reflect across the y-axis, you change the x. You do the opposite. When you're doing your problems in your math, make sure that you take your pencil and physically show that it crossed the x-axis, like this. He laid that arrow to show that it crossed the x-axis. So always double check that you're crossing the correct axis. So again, if you want to cross the x, you change the y. If you want to cross the y, you change the x. Let's take a look at our workbook pages. Today we are taking a look at pages 25 and 26 in our workbook, the red Smarter Balance Practice workbook. If you don't have a workbook, you're going to have to draw these coordinate planes in your spiral notebook. Okay, So quadrants. Remember when we have a quadrant system, we have 4 quadrants and it is labeled in a counterclockwise direction. So if we have a positive and a positive, so positive x, positive y, that means we're going to the right of x and we're going up, we're going to be in quadrant 1. So 3, 4 goes in quadrant 1, for example. If we have a negative x but a positive y, we're going to be in quadrant 2. So for example, negative 1, 3 is going to be in quadrant 2. So remember when we're doing quadrants, it's 1 on the top right, 2 on the top left, 3 on the bottom left, 4 on the bottom right when you draw a 4-part quadrant coordinate plane on your spiral notebook. Question number 2. Mia's house is located at point 3, 4 on a coordinate plane. The location of Keisha's house is the reflection of Mia's house across the y. So remember what we learned in the video. When you want to reflect across the y, you change the x. So change the x value, write your new ordered pair, and then tell what quadrant is it. Is it in quadrant 1, 2, 3, or 4? So 2 answers here. Question number 3. Point A is at 2, -3. It is reflected across the x-axis to point B. So write the coordinates for point B in the box. Remember, if you're reflecting across the x-axis, you change the y. Next step, point B is reflected across the y-axis to point C. So take your answer from point B, change the x, because to cross the y, you change the x, and put the coordinates of point C. You also might want to draw a coordinate plane, graph the points, and double check that your answers are crossing the correct axis. Pause your video until you're ready to go to number 4. Okay, on question number 4, it says Rex's house is located at point 2, -5 on a coordinate plane. The location of Terrell's house is the reflection of the coordinates of Rex's house across the x-axis. So again, if you want to cross the x, you're going to change the y. Write the coordinates for Terrell's house, and then tell me what quadrant is it in. Quadrant 1, 2, 3, or 4. For number 5, it says point R is at 4, -5, and is reflected across the y-axis to point S. So write the coordinates for point S in the box. Then point S is reflected across the x-axis to point T. So reflected across the x and write the coordinates for point T. I would draw a coordinate plane, graph your points, and make sure you're crossing the correct axis. Question number 6. Again, telling what quadrant they're in. Remember, when you have 4 quadrants, the top right is quadrant 1, the top left is quadrant 2, the bottom left is quadrant 3, and the bottom right is quadrant 4. So draw yourself a little picture, label the quadrants to help you. And then tell me what point is in quadrant 1, and so on for each of these. Pause your video until you have all of your workbook completed, please. Okay, so looking at question number 1, the quadrants, remember quadrant 1 is top right, then quadrant 2, top left, quadrant 3, bottom left, quadrant 4, bottom right. So if it's positive x and positive y, it's going to be up here in quadrant 1. So that's why 3, 4 is in quadrant 1. If it's negative x, you're going this direction, but positive y, you're going up, so it's in quadrant 2. So negative x, positive y is in quadrant 2. And then quadrant 3, they're both negative. And in quadrant 4, you have a positive x, but a negative y. In problem number 2, the reflection will be in quadrant 2, because if you're reflecting across the y-axis, you're going to end up over here. Question number 3, -2, 3 is the point of C, -2, 3. Because if you start at A and you reflect across the x, you're going to end up at b, 2, 3. To get to c, you flip the x, and now we're at negative 2, 3. Question number 4. Rex's house is at positive 2, negative 5, and Terrell's house is at positive 2, positive 5. Question number 5. R is at 4, negative 5. We want to reflect across the y, so we change the x. So S is at negative 4, negative 5. Then we want to cross the x-axis, so we change the y. So T is at negative 4, positive 5. On question number 6, negative 5, positive 2 is in quadrant 2. Negative 1, negative 9 is in quadrant 3. Positive 7, positive 2 is in quadrant 1. Positive 6, negative 4 is in quadrant 4. Positive 5, negative 4 is in quadrant 4. And negative 3, positive 3 is in quadrant 2. If you have any questions about graphing, please feel free to email me. Have a great day.